We can see about transition and diffusion capacitance and switching current structure. Here, while we are seeing this transition and diffusion capacitance, the first one is the maximum forward current. In the case of maximum forward current, as its name implies, the maximum forward current allowed to flow through the devices. And in the case of the diode is conducting in the forward bias condition, it has a very small on resistance across the PN junction, and therefore power is dissipated across the junction in the form of heat. Therefore, it exceeds the value which causes more heat to be generated across the junction, and the diode will fail due to the thermal overload, usually with the destructor consequences. And also the operating diodes across across the operating diodes around their maximum current ratings. It is always best to provide a additional cooling to dissipate the current produced by the diode. For example, while we are taking the small diode, that is 148, the single diode has a maximum current ratings of about 150 nanoampere with a power dissipation of 500 nanoampere at 25 degrees Celsius. And also the resistance must be used in series with the diode to limit the forward current, though it is to be below this value. Now next we can see about peak inverse voltage. Here the peak inverse voltage or the maximum reverse voltage is the maximum allowable reverse operating voltages that can be applied across the diode without reverse bias, that is without reverse breakdown and damage occurring in the device. And here the peak inverse voltage is an important parameter that is mainly used for rectifying the diode in AC rectifier circuits, which reference to the amplitude of the voltage while the sinusoidal signals changes from positive to the negative value on each and every cycle. Next one is the forward power dissipation. When we are considering the signal for diodes having the forward power dissipation, the rating is the maximum possible power dissipation of the diode when it is the forward diode. When current flows through the single diode, the biasing of the PN junction is not perfect, and it offers a small resistance to the flow of current, resulting in the power being dissipated in the diode in the form of heat. And also in the case a small signal diodes are nonlinear devices with the resistance of the PN junction is not constant, and it is the dynamic property that we cannot use the Ohm's law to define the power in terms of the current and resistance or voltages and resistance as we can for resistance. And here to find out the power that will be dissipated by the diode, we must multiply the voltage drop across it times the current flowing through the diode, that is PD equal to V into L. Here now we can see about maximum operating temperature. Here in the case of maximum operating temperature, it relates to the junction temperature of the diode and it relates to the maximum power dissipation. And here the maximum temperature allowable between the structure of the diode, and it expresses the units of degrees centigrade per watt, and this value is linked closely to the maximum forward current of the diode, so that this value, the temperature, that is the temperature of the junction is not. Here the maximum power current of the device, so that this value, the temperature of the junction is not exceeded. Therefore the maximum forward current will also depend upon the abundant temperature in which the device is operating, so that the maximum forward current is usually quoted for 2 or more abundant temperatures. And here next one is the switching characteristics. While we are seeing here, this is the diode, that is the diodes are often used in switching mode when the applied voltage bias voltage of the PN junction diode is suddenly reversed in opposite direction and reaches a steady state at an interval of time that is said to be the recovery time. And here the forward recovery time is defined as the time required the forward bias or the current to reach a specified value after the switching diode from its reverse to forward bias state. When the PN junction is forward bias, the majority electron concentration in P type is linear, and here if the junction is suddenly reversed at T1, then because of stored electronic charges, the reverse current IR is initially the same magnitude as in the forward current, and this is the diagram. And here the diode will continue to conduct until the injected or excess majority charge carriers has dropped to 0. And here the applied voltage Vi equal to Vf for the time up to the Tn is the direction to the forward bias condition. And here the resistance RL is larger, so that the drop across this RL is large, and when compared to the drop across the diode, therefore the current is given as I equal to Vf by RL equal to I. And also here during the time interval from T1 to T2, the injected majority carriers from remained stored, and hence this interval is known as the storage time. And here the time between T2 and the instant T3 when the diode has recovered dominantly is known as the transition time. The recovery is said to have been complete when even the majority carriers removed from the junction having diffusion to the junction and crossed it. When the junction transition capacitance across the reverse bias junction has got charged through the external resistance RL to the voltage minus VR. In order to minimize the effect of reverse current, the time period to the operating frequency should be minimum approximately that of 10 seconds. And here the recovery time can be reduced to shorten the length of P region in the PN junction diode. And here the stored storage and the switching time can be reduced by introducing of gold impurities into junction diode by diffusion, and the gold dopant is known as the lifetime killer, increases the recombination rate and removes the stored minority carrier. This technique is used to produce the diode and other active devices for high speed applications. That's all. Thank you.